Imagine venturing into the vast, inky blackness of space. You're an astronaut, a pioneer on the final frontier. You think your spacecraft is pristine, a sterile bubble of human ingenuity. But you'd be wrong. We are never truly alone. Tiny, unseen life forms hitch a ride with us. Among these microscopic travelers are fungi. Yes, mold. In space. It sounds like science fiction, doesn't it? But it's a very real and very serious challenge. These aren't alien life forms from distant galaxies. They come from us, from our supplies, from the very air we launch. Every time a new crew or cargo arrives at the International Space Station, ISS, there's a chance for new microbial introductions. These fungi find the warm, humid environment inside a spacecraft quite cozy. Now, why should we care about a little fuzz growing in a corner? On Earth, mold might just be an annoyance in your bathroom. But in the unique, isolated, and high-stakes environment of space, mold transforms from a mere nuisance into a significant threat. It can affect the health of our brave astronauts. Understanding and controlling these fungal invaders is crucial for the present and future of space exploration. So, what exactly is this mold we're talking about? It's a type of fungus, a very diverse kingdom of organisms. Think mushrooms, yeasts, and yes, the fuzzy stuff. Molds reproduce by releasing tiny particles called spores. These spores are incredibly resilient. They are survivors. They can float through the air unseen, waiting for the right conditions. And when they find a suitable spot, some moisture, some food, they settle down and grow. They form colonies, visible as patches of green, black, or white. On Earth, mold plays a vital role in decomposition. It breaks down dead organic matter, recycling nutrients. But when it grows indoors, in our homes or workplaces, it becomes a problem. It can trigger allergies, cause respiratory issues, and damage building materials. Now, imagine transplanting this earthly issue into a sealed metal can hurtling through space. The International Space Station is a marvel of engineering. It's a closed-loop system, recycling air and water to sustain life. This creates conditions that can be surprisingly hospitable to mold. There's warmth from equipment and astronauts. There's moisture from human breath, sweat, and condensation. And there are plenty of food sources, dead skin cells, fabric fibers, even some plastics. This terrestrial troublemaker has indeed gone galactic, and it demands our utmost attention and ingenuity. Our astronauts are heroes. They endure rigorous training and face incredible risks. The last thing they need is an invisible enemy attacking their health from within their own habitat. Yet, mold poses exactly this kind of insidious threat. In the confined environment of a spacecraft like the ISS, astronauts are constantly exposed to whatever is in the air, including those hardy, ever-present mold spores. They breathe them in, day after day. For some, this can trigger allergic reactions. Think itchy eyes, runny noses, skin rashes, coughing, and wheezing. Imagine dealing with a persistent allergy attack in zero gravity, while trying to perform complex scientific experiments or critical repairs. Some mold species can even produce mycotoxins. These are toxic compounds that can lead to more serious health problems. Furthermore, spaceflight itself can affect an astronaut's immune system. Studies have shown that microgravity and cosmic radiation can weaken immune responses. This makes astronauts potentially more susceptible to infections. The health of the crew is paramount. Their bodies are, in a way, part of the mission hardware. This means keeping their living and working environment as free from harmful microbes as possible. Mold doesn't just make astronauts sneeze, it has an appetite. A surprisingly diverse and destructive appetite, in fact. These microscopic organisms can wreak havoc on the very systems that keep a spacecraft functioning. The ISS is packed with cutting-edge technology. Computers, navigation systems, life support machinery, scientific instruments. Much of this equipment is made from materials that mold can, quite literally, eat. Plastics, rubber seals, insulation, coatings, even some types of glass. Imagine mold growing on a critical circuit board. The fungal filaments, called hyphae, can absorb moisture. This moisture can lead to corrosion or even short circuits. A tiny patch of mold could potentially disable a vital piece of equipment. Consider the cooling systems or air vents. If mold grows there, it can form biofilms, slimy layers of microorganisms. These biofilms can clog filters and pipes, reducing efficiency. This could lead to overheating or poor air quality, serious problems in a sealed environment. Mold can slowly degrade materials, making them brittle or weak. Over time, this can compromise the structural integrity of components. Seals can fail, wires can fray. Protecting this incredible asset from the relentless encroachment of fungi is a constant and critical engineering challenge. Space, the perfect petri dish? You might think space with its radiation and vacuum would be hostile to life, and outside the spacecraft it certainly is. But inside, things are different, and microgravity adds a strange twist. Does this unique environment give mold an advantage? In some ways, yes. It can turn parts of a spacecraft into an unintentional petri dish. Consider how water behaves in space. It doesn't just flow downwards, it clings to surfaces due to surface tension, forming globules. This means moisture can accumulate in unexpected places, creating hidden damp spots. Perfect little havens for mold spores to germinate and thrive. On Earth, gravity pulls heavier particles like spores downwards. They eventually settle on surfaces, mostly floors. In microgravity, spores just float, indefinitely. They can travel further and reach almost any surface. This widespread dispersal makes containment much harder. A small patch of mold in one module can quickly spread its spores throughout the entire station. The ISS becomes a unique laboratory for studying microbial behavior in extreme conditions. This knowledge is vital, not just for dealing with mold on the station, but for designing future spacecraft for long-duration missions. Cosmic contamination, a history of fungal foes in spaceflight. The problem of mold in space isn't some new, shocking discovery. It's a persistent stowaway that has accompanied us on our journeys beyond Earth for decades. Space agencies have been aware of and battling microbial contamination since the early days of human spaceflight. The lessons learned from past encounters inform our current strategies. Perhaps the most famous example comes from the Russian space station, Mir. That stalwart outpost orbited Earth for 15 years. Mir experienced significant issues with mold and bacterial contamination. Astronauts and cosmonauts reported visible mold growth in several modules, sometimes large patches of it behind panels, on cables, even on portholes. Condensation was a major culprit, a constant battle in the aging station. There were stories of cosmonauts finding globules of water, sometimes teeming with microbial life, floating freely or hidden behind equipment. The Mir experience was a stark wake-up call. It highlighted how quickly and extensively microbial communities could establish themselves in a closed habitat over long periods. Even before Mir, there were concerns. During the Apollo missions, microbes were found inside lunar modules after their return. The mold patrol battling biofilms on the final frontier. Mold is a problem. On the ISS, there's a dedicated mold patrol. Prevention, detection, and remediation. Keeping the station clean and healthy. Astronauts are also part-time janitors and microbiologists. Prevention starts on Earth. Components are cleaned and sterilized. New procedures minimize microbial load. Controlling moisture is key. ECAL-SS manage humidity and recycle water. Air is filtered through HEPA filters. Detection involves regular monitoring. Samples are analyzed on board or on Earth, identifying microbes and their locations. Remediation protocols kick in, cleaning with antimicrobial wipes or solutions. Beyond the ISS, fungal challenges for Mars and earthly insights. The fight against mold isn't just about the International Space Station. It has profound implications for the future of human space exploration. Think about upcoming missions, a return to the Moon and eventually Mars. These will be much longer journeys in even more isolated environments. The challenges of microbial control will be magnified. Imagine being millions of miles from Earth on a multi-year mission to Mars. You can't just send up a resupply ship with new filters or cleaning supplies easily. On a long-duration mission, like a trip to Mars, the spacecraft will be a truly closed system. Any mold that gains a foothold will have years to grow and spread. The consequences for crew health and equipment reliability could be dire. Therefore, designing spacecraft that are inherently resistant to microbial growth and developing robust, autonomous systems for environmental control and decontamination is absolutely critical. We need to get this right before we send humans on such epic voyages. Failure is not an option when you're that far from home. There's another angle too, planetary protection. When we send landers, rovers, or eventually humans to other celestial bodies, we have a profound responsibility not to contaminate them with earthly microbes. Our fungal future taming mold for exploration and beyond. Mold in space. A tiny organism often overlooked on Earth becomes a formidable challenge beyond our atmosphere. It's a testament to the tenacity of life, and to human ingenuity and our drive to explore. We face this challenge with science, technology, and perseverance. Managing these microbial hitchhikers is crucial for sustained human presence in space. Whether on the ISS, Moon, or Mars, we must master our microbial environment. This means understanding, predicting, and designing healthy, resilient habitats. The future of space exploration depends on it. The quest to control mold in space ensures our future.